Hello friends, welcome to our channel Red's Info Hub. In this session, let us discuss briefly about fundamental forces in nature. Are you ready? As if you are new to our channel, please subscribe our channel and click on like button, right? And don't forget to share to your friends as well. As let us get into the concept, guys. Yeah, as welcome back to our beautiful channel Red Info Hub. Yes, guys, please don't forget to subscribe our channel and click on bell button. Okay, as let us see what are fundamental forces in nature. Right, in the entire nature or universe, whatever forces we come across, so all the forces which we come across in nature are classified into four categories, namely gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Got it? So let us see briefly what are these and what are a few properties of these forces, and let us also discuss about what kind of questions you may get in a NEET or JEE point of view. Simple theory-based questions only you may come across. Let us see few questions as well. Right? See, gravitational force. I hope these points are clearly visible for you guys. Yes, so gravitational force, it is the I can say it is the weakest forces. It is the weakest forces in nature. Gravitational force is the weakest forces in nature. Okay, you have to remember this, guys. Right? And what is gravitational force? According to Newton, gravitational force between any two objects having masses m1 and m2 and separated by distance r is given by fg is so f suffix g is equal to gravitational force is equal to g capital G into m1 m2 by r square, or it is proportional to product of masses and directly proportional to product of masses and inversely proportional to square of the distance between them. So we also call this force is inverse square force, or this force obeys inverse square law, right? And this gravitational force is always attractive in nature, got it? And this gravitational force is a long range force, means it acts between any two objects within a small distance, like in millimeters or micrometers or even in femtometers, like within a nucleus. Within nucleus, the gravitational force may act between nucleons, like proton or neutron. Also, gravitational force will act. Whereas it also acts between any two objects which are at a huge separation, like the gravitational force acts between Earth and the Sun, Earth and Moon, or between any two planets for that matter. Got it? So we can say it is a long range force, means it present everywhere in the universe, or you can say it is the most dominant force. Dominant force means it present everywhere. That's why it is the most dominant force in the universe. Gravitational force doesn't need any intervening medium. Means if you have any two masses m1 and m2, if these two masses are in air, or if these two masses are in any, say for example, in water medium or any liquid medium, or wherever it is, wherever these masses are, the force acting between them, and if they're separated by some distance r, the force between them is given by this, irrespective of the medium between these two. Is it clear? So the gravitational force does not depend on the medium between the masses, and it is a central force. What does this central force means? So this means the force acts along the line joining the centers of the two masses. So such kind of force is called central force. And you can also say this gravitational force is a conservative force. This is also conservative. This is also conservative in nature. Means the conservative force can be defined as the force, right, which involves in doing work. So that if the work done by a force is position dependent, not path dependent, such forces are called conservative forces. So here gravitational force is also considered to be a conservative force. Okay, these are few brief and important points about gravitational forces. Now let us see what are few important points or properties of electromagnetic forces. When you say electromagnetic forces, electric forces or electrostatic forces and magnetostatic forces together can be called as electromagnetic forces. Okay, so we can say that the force between any two charged particles is called electromagnetic force. Really specifically speaking, it is called electrostatic force. And if the charges are at rest, is obviously we call it as electrostatic force. Whereas if, and in this case, when the charges are at rest, the force between them is given by Coulomb's law. Whereas if the charges are in motion, they produce magnetic field, and this electric along with electrostatic field or electric field, these fields will interact with one another, and that force of interaction between electric and magnetic fields is called electromagnetic force. So what is electromagnetic force? The force of interaction between electric and magnetic fields, right? And these uh, uh, can be separately or individually can be treated as electrostatic force and magnetostatic forces also. So electrostatic force also come under electromagnetic force. So that is the force between any two charged particles. And these forces between charges can be either attractive or repulsive depending on the nature of the charge. Between, already you might have studied in your lower classes that the electrostatic force between any two unlike charges is attractive and two like charges will be repulsive. So electromagnetic forces can be attractive or repulsive. Got it? And you have to remember that these electromagnetic forces are very strong. You can say extremely strong compared to gravitational forces. So for example, between any two protons, electromagnetic force is 10 power 36 times gravitational force. So that much stronger, very strong, extensively strong it is between any two charged particles. Got it? And we can say that these electrostatic forces are also long range forces, just like gravitational forces. Long range forces means, whatever, irrespective of the distance, it may be meters or kilometers or hundreds or thousands of kilometers also it may act, but the force may varies. So but electrostatic force between any two charged particles according to Coulomb's law is given by 1 by 4 pi epsilon naught. We can express it as K into Q1 Q2 by R square. So because it is also following that is proportional to 1 by R square, can say that electrostatic force or electromagnetic force also obeys inverse square law. Can say that just like gravitational force, it also obeys inverse square law. And electrostatic or electromagnetic force is also central force. Central force means it acts along the line joining between the centers of the charges. Right? It is a long range force, just like gravitational force. It is a central force, just like gravitational force. It is a conservative. You can say that one more point. It is a conservative force, just like gravitational force. And you can say it is a charge dependent, whereas gravitational force is a charge independent. It is charge in electromagnetic force is charge dependent, unlike a gravitational force, you can say. Okay, based on these points only you may get the questions done. Okay, you have to remember these points. Next, let's see about strong nuclear force. Strong nuclear force. So the force which binds the nucleons within the nucleus. You know what are nucleons? Protons and neutrons together are called as nucleons, right? So the force which binds the nucleons called protons and neutrons within the nucleus is called strong nuclear force. And you have to remember this one of the very important point, that It is the strongest force in the universe. Which is the strongest force in the universe? Strong nuclear force, or simply you can say nuclear force. Whereas what is the weakest force, or which is the weakest force in the universe? Gravitational force. Strongest force in the universe? Nuclear force, or strong nuclear force. Is it clear, guys? Whereas you have to remember that this strong nuclear force is 100 times stronger than electromagnetic force. That means nuclear force is equal to 10 power 2 times or 100 times the electromagnetic force. Okay, so that means, for example, if you consider within the nucleus, protons, neutrons will be there. Between protons and protons, because of the charge, electrostatic force of repulsion will be there, and the nuclear force also will be there. So here nuclear force is stronger, 100 times stronger, 100 times stronger than electromagnetic force of repulsion. That is the meaning of it. And this strong nuclear force is the charge independent. That means it acts equally between protons, and protons, neutrons, and neutrons, within the nucleus. Within the nucleus. Is it clear? And here you have to remember a few more points about this strong nuclear forces. Are nuclear force is a short range force. That is, it acts within the range of 10 power minus 15 meters only. Means within the nucleus only strong nuclear forces will present. Outside nucleus they will not present. And strong nuclear forces are spin dependent. About the concept of spin, you will study in higher classes. Here we are just in this level, we no need to study, but better to have an idea about spin dependency of nuclear forces. Nuclear forces are spin dependent. Okay, and that means if any two particles are having same spin, nuclear force will be larger. Opposite spin, it will be weaker, right? And these are non-conservative forces. Already you know what are conservative. So nuclear forces are non-conservative. You have to remember these points about nuclear forces, right? Next, let us see briefly few points about weak nuclear forces. So weak nuclear forces, right, appear only in certain nuclear processes or reactions, like beta decay of nucleus. What is beta decay? So beta decay is when a nucleus emits an electron, then we can say that it is undergoing beta decay. Usually whenever an electron is emitting, you can say beta decay is taking place. Electron emits along with a particle, an uncharged particle called neutrino, right? So the force which acts between an electron and a neutrino in beta decay is called weak nuclear force. Copy it down this wise. Just try to have an idea about what is the conceptual point. The force between electron and neutrino in beta decay is called weak nuclear force, and it is also a short range force. That is, this also exists within the distances of 10 power minus 16 meters, within the nuclear dimensions of 10 power minus 16 meters. And these weak nuclear forces are also non-conservative forces. These are also non-conservative forces. So these are few important points you have to remember about these individually, about fundamental forces in nature. What are those? Gravitational forces, weak nuclear forces, electromagnetic forces, and strong nuclear forces. Just you can remember them in any order. Okay. Now let us try to have a brief discussion about the relation between relative strength. How the relative strengths will appear. If you consider nuclear force is having 1 unit of strength, then electromagnetic force will be having a strength of 1 by 100 times. It is lesser strength. Electromagnetic force will be having 1 by 100 times lesser strength than nuclear forces, so that we can express it as 10 power minus 2. Similarly, weak nuclear forces are having 1 by 10 power 13 times lesser strength, or 10 power minus 13 times that of nuclear forces. Whereas gravitational forces, strength of gravitational forces is 10 power minus 39 times that of nuclear forces. So the ratio you can take in this way. Then 10 power negative powers, 10 power positive powers, if you want to take, the order you can take like this. The ratio among gravitational forces, weak nuclear forces, and electromagnetic forces and nuclear forces can be taken like this. If you take gravitational force strength is 1 unit, Then weak nuclear forces will be 10 power 26 times that of weak nuclear forces, and electromagnetic forces are 10 power 37 times that of gravitational forces, and nuclear forces are 10 power 39 times that of gravitational forces. This gives an idea of relative strength between what these fundamental forces in nature. Right here, you can see few more additional points now. So gravitational force, here, if you consider nuclear force is having 1 unit, comparing with this, electromagnetic forces will be 10 power minus 2 times, weak nuclear forces will be 10 power minus 13 times, and gravitational forces will be 10 power minus 39 times. And here, the ranges of these forces you can have briefly about. So, nuclear forces will be having are said to be short range forces. Short range forces means they will exist within the nucleus or nuclear size, the nuclear dimensions, that is of the order of 10 power minus 15 meter. If it is not visible, guys, already I have given you this in the previous slide. Okay, the range where in which range they will appear. They will exist. They will exist in the range of 10 power minus 15 meters range only. They will exist. Whereas electromagnetic forces are long range forces. You can say the range is up. The range is extended up to infinity. So we can call them as long range forces. Whereas weak nuclear forces or weak forces are also short range forces, or you can say that their subnuclear size, they exist in subnuclear dimensions, means of the order of 10 power minus 16, 10 power minus 16 meters range. Whereas gravitational forces are also long range forces, or you can say they uh, their effect will be there up to infinity relatively. Okay, whereas a few more points here I would like to give, that is they operate among all objects in the universe, which are the ones gravitational forces. Whereas weak nuclear forces, some elementary particles, particularly electron and neutrino, already we have discussed at this point, right? And electromagnetic forces operates among charged particles only. That's why these are called as the charge dependent forces. Whereas strong nuclear forces, right, operates among nucleons, like I can say heavier elementary particles, nucleons. Okay, so why this again another word is given here is because nucleons can be subdivided into some other sub-elementary particles that we are not entering into that particular part. Okay, so we can also give the what you call the relative strength in this way. So gravitational forces are having less strength than weak nuclear forces, which are having less strength than electromagnetic forces, which are having less strength than nuclear forces. The other way also you can consider. So usually questions can be asked again based on these points also. Okay, guys, so try to remember this ways of representation, representing the relation among different forces. Okay, now let us see briefly few questions, simple questions, or what kind of questions can be asked based on fundamental forces in nature. So the first question is, choose the correct statement among the following. The first statement says gravitational force is the weakest force. Second point says electrostatic force is weakest force. Third point says nuclear force is weakest force. All of the above are weakest forces is the fourth option. All of the above are weakest forces? No. And I can say that electrostatic force is not weakest, and nuclear force is not the weakest. Of course, gravitational force is the weakest force, right, in the universe. So first option is the right one. Is it clear, guys? Next question. Let us see. The next question is, the force which obeys inverse square law is. The options are gravitational force, electromagnetic force, nuclear force. Fourth option says both 1 and 2. What are 1 and 2? Gravitational force and electromagnetic force. Yes, which is your correct answer? Yes, very good. Gravitational force obeys inverse square law. Electromagnetic force or electrostatic force is also obeys inverse square law, because gravitational force can be given as Fg is equal to G m1 m2 divided by r square. It follows inverse square law. And electromagnetic force, electrostatic force is a part of electromagnetic force. According to Coulomb's law, it is given by K, that is 1 by 4 pi epsilon naught into Q1 Q2 by r square. So this is also inverse square. This also obeys inverse square law. So 1 and 2 are correct. That is given in this option. So you have to be careful, Anna. So fourth option says both 1 and 2 are correct. So fourth option is correct, right? Very good. Next question. Choose the correct statement. Strong nuclear forces are charge independent. Weak nuclear forces are charge independent. Gravitational forces are charge independent. All of the above. Actually, electromagnetic forces are the only forces which depends on charge. Gravitational forces does not depend on charge, and weak nuclear forces and strong nuclear forces also does not depend on charge. So all of these are correct. So fourth option is the right one. Is this clear, guys, everyone? So if you get any confusion, go back to the previous slides and refer the points about individual forces and come back and try to answer these questions, right? The next question is, choose the correct statement. The range of strong nuclear force is 10 power minus 15 meters. Range of weak nuclear force is approximately 10 power minus 16 meters. And third option says both 1 and 2 statements are correct. Fourth option says none of the above is correct. As we have discussed while discussing those strong and weak nuclear forces, that the range of strong nuclear forces, then strong nuclear forces exist within the nuclear dimensions. That is, the size of nucleus is 10 power minus 15 meters. Whereas uh, a range of weak nuclear forces is of the order of 10 power minus 16 meters. Within the atom, it exists when the nucleus undergoes beta decay. So both of these are correct. That means option 3 says both 1 and 2. So this is correct. Option 3 is correct. Got it? Next question. Let us see the next question. Yes, next question is match the following. Match the following. See, here in the first column, forces are given. In second column, relative strength among these forces are given. Then options are given. So you have to choose which option is correct. Under the forces, we have gravitational force, weak nuclear force, electromagnetic force, nuclear force. Under relative strength column, we have 1, 10 power 25, 10 power 36, 10 power 38. Right? So which of these are related? That matching relations you have to select here under the options. Already we know that. Here they are given in positive powers. Positive powers means you have to consider gravitational force strength as unity. Just if you remember, see here, gravitational force strength you have to consider as unity. Then the powers you can consider in 10 powers. Here 10 power 39 you have. There if you come, just if you observe, his 10 power 38 is given. That means this powers also approximate powers. This is not fixed powers. Then 1 or 2, you can powers may change approximately. Instead of 10 power 37, you may come across 10 power 36 or 35, like plus or minus 1. Here also for 10 power 38 or 37 also may come across. So if accordingly this, but these two are 100 times related with the nuclear force is 100 times stronger than electrostatic force, electromagnetic force. In that way, we have to just follow the relation. Now let us see that, right? See, a gravitational force, if you consider as having 1 unit strength, then weak nuclear forces will be having 10 power 25 times stronger than this. Electromagnetic forces are 10 power 36 times stronger than gravitational forces. Nuclear forces are 10 power 38 times stronger than gravitational forces. So we can say that the correct option is 1A, 2B, 3C, 4D. 1A, 2B, 3C, 4D is given in first option. So the first option is the correct one. Is it clear, guys? Right? So like these kind of questions you may come across, but in NEET point of view, single objective questions, single correct option questions you will come across. In JEE point of view, this kind of questions may come across. So try to answer any kind of competitive exam. So try to have an idea about how to attempt this kind of questions. As guys, I hope you have followed and understood all these points whatever we have discussed. Okay, again, I'm requesting the students who are new to the channel, please don't forget to subscribe our channel and click on like button. Okay, and try to share with your friends as well. Okay, so thanks one and all the friends. Take care, everyone. Bye bye. Take care, everyone.